Welcome to Tales from the Rabbit Hole. I'm your host, Mick West. My guest today is Donald Friedman, a licensed professional engineer with 30 years of experience as a structural engineer and also as a forensic engineer. Don is a founder of Old Structures Engineering, and he's also taught at the Pratt Institute and various other places, including Columbia University. He's presented at conferences, he's authored numerous articles, and written 5 books related to construction, renovation, and engineering. One of those books is An Engineer's Work at the World Trade Center, published in 2002, which tells of his experience working as an engineer at the World Trade Center site after 9/11. I talk with him about how his experience at the World Trade Center and his knowledge of engineering intersects with the world of conspiracy theories. Okay, right. Well, first of all, thanks again for doing this. This is very good. Thanks for making the time.
You're welcome.
You are the author of the book, An Engineer's Work at the World Trade Center, which you published in 2002, which details your experience working as an engineer at the World Trade Center site. How did that actually start? Can you say how you actually got onto the site? Like, what happened and how you were assigned there?
At that time, I was an employee of Thornton Tomasetti Engineers. I was an associate, and I was the director of historic preservation for the company. And my understanding of it is that on the afternoon of September 11th, 2001, New York City hired Thornton Tomasetti to coordinate the engineering work that would be required for cleanup. Basically, the city doesn't have enough structural engineers to do the job, and they all have their regular work to do. So if all of them were on site, nothing else would be happening. So we were, all of the employees in the Thornton Tomasetti New York office were informed that afternoon that if we agreed to it, it was voluntary, we would be going to the site the next day, 12th. And I volunteered. The way it eventually was organized, it took a few days for this to solidify, was that there were, at any given moment, 5 teams on site. There was one more or less stationed at each of the 4 corners of the site, which is a slightly skewed trapezoid. And my team was roving around looking for old buildings. So there are a number of historic landmarks near the site, and some few buildings that are not landmarks but are not modern structure. And since that's my specialty, okay, we were going to be working on that. So starting on the 12th, I was down there as part of that effort. I was there for 9 days in a row at the beginning, and then every 3rd or 4th day afterwards into November.
Yeah, my understanding of what an engineer does is basically that you are studying a structure to determine the loads on that structure and to make sure that structure can support the loads and any additional loads that might come along, and then design modifications or additional structures if needed to support those loads, basically. Is that kind of a good kind of overview of what an engineer does?
It's certainly a big piece of it. If you work primarily with existing buildings, as I do, the beginning of almost every project is an investigation of the existing building. If we have drawings, we need to see that they're correct. And most of the time we don't have drawings, we need to figure out what the structural systems are. And whether we have drawings or not, there's always the question of, well, what's the condition of the existing building? Because all materials age and gradually fall apart. So just because a building is standing doesn't mean that all of the structure is in good condition.
Right, yeah, like I know in my apartment we got a lot of termites taking out structural beams, and we had to bringing an engineer to add on an extra steel beam. So you mentioned you do forensic engineering as well. Is that kind of like what you're talking about there, examining building, or is that like examining when something collapses?
Forensic engineering is most often trying to figure out the reason for a collapse, and the court system being what it is, who's responsible, if anybody. Some things are truly accidents, some things are truly unavoidable, but very often somebody has somehow made an error that led to a collapse. So
you would do a study and maybe get called as an expert witness in litigation?
Yes, it's not the main focus of my work.
Right.
It's something I do sometimes. Yes.
So when you first arrived there, one of the things that struck me in the book, and I think struck a lot of people who were at the site, was that the contents of the buildings like the things like desks and things like that, had largely vanished. And you see these large beams and these big chunks of concrete and lots of dust, but a lot of the structure had actually vanished. This is something that people point to sometimes as being like evidence of something, like there must have been some kind of explosives in the building. Was this something that struck you at the time as being inexplicable, or did it kind of make sense to you at the time?
It was surprising, but when I'm talking about what I saw on site, I should, or my thoughts on site, I should mention that I was talking to other engineers that I know pretty much the whole time, so I can't necessarily say that everything I say is something I thought of first. A lot of times it's sort of part of a group conversation, and I'm just reporting it to you now.
Okay.
What became pretty clear after the first day on site was that the contents of World Trade Center 1 and 2 had been pulverized. Anything that could break was broken. So what survived the collapses, was ductile metal. So you saw pieces of steel. I saw once a huge pile of elevator cable that must have come from one of the upper shafts. And the other thing that survived was paper, because if you think about an office building, most of the volume of space on the inside is air.
Uh-huh.
And as the floors pancake down, that air has to go somewhere, and it goes out. So loose paper that was sitting on somebody's desk got blown outwards as the floors pancaked down. And as a result, there was paper all over the place on top of this, or mixed in with this very thick layer of dust that was pulverized concrete and gypsum board, ceiling tiles, things like that, cubicles.
Yeah.
Along with this, the other thing that got pulverized were bodies.
Yeah.
And, that's why they had to resort to DNA testing in order to identify bodies, because something like dental records was hopeless, because there weren't big enough pieces of bodies intact. I don't think anybody's claiming 3,000 people vanished.
No, it's quite amazing to think of. And when you got there, when you first got to the site, what were the first engineering tasks that needed doing on the site?
On the 12th, so if you think about it, everybody knew 3 large buildings collapsed. Everybody knew a number of smaller buildings were hit by rubble, hit by debris. But nobody knew how, did debris hit buildings a block away, 2 blocks away? There's no way to tell. So what was the only thing engineers were doing on the 12th was looking at the buildings at sort of the perimeter of the site. And the original perimeter was quite large. It went 2 blocks to the east, so it went a block east of Broadway, for example, at which point you're, 200 yards from the site.
Right.
But if you think about it, that is, less than the height of the towers.
Yeah.
So it's not inconceivable something could have gone that far. So what we were all doing was investigating. We were basically going up on the roofs of buildings, and there were I think something like 400 or 500 buildings checked, going up on the roof to see if there was any sign that something had hit. And for example, the post office that's north of the site, they found an engine from one of the planes on the roof of the post office. So obviously debris had moved around a bit. And if you have enough people and you do it methodically, we went through a lot of buildings on the 12th and on the 13th. So that was the first engineering task. There were basically 2 groups of people from Thornton Tomasetti. There was one group doing site work, which is where I was pretty much the whole time, and the other group was checking where it was safe to put cranes, because it was obvious the cranes were going to be needed to lift the heavier pieces of debris.
Yeah, so that was quite a big part of the not big part of the book, but you talked about it a lot, like the unusually large cranes that they had there. Now, you talk about kind of going, you started at the perimeter, the furthest extents of the damage. How would you characterize what was actually at the perimeter in terms of what was falling? You mentioned an engine, but that's obviously something that kind of shot out as the plane shot out. So would it be exterior columns and the cladding of those columns at the perimeter?
I I didn't see anything like that. What I saw I only saw the buildings I checked.
Okay.
And I was on Maiden Lane east of Broadway and a couple of blocks close by, which are quite far from the site. And I think perhaps more importantly, they're to the east of the site. And the planes that hit, one was traveling north, one was traveling south. So any debris spread would not be likely to head east. So what I saw on the roofs was the lightweight debris, which is to say dust and a little bit of paper.
Kind of moving further in towards the middle of the site, you would start to see columns and beams and things. One of the things that really struck me in the book, which I mentioned in the email, was your description of the core columns and how they had kind of snapped apart at the seams. This is something you observed quite a lot.
Well, yes, the steel from towers 1 and 2 really stayed within the footprint of the World Trade Center site. I mean, it went a little bit onto the surrounding streets, but it's just too heavy. The force pushing it outwards was just very small compared to gravity, and therefore it went more or less straight down. So you had to get up to the site, right up to the World Trade Center site itself, to see substantial amounts of steel. The furthest pieces of steel I saw were the ones stuck into, I guess it would be 3 World Financial Center and 130 Liberty Street. Mm-hmm. So they had made it across West Street and across to the south side of the site. And it's not a negligible distance, but that's about the furthest I saw any steel.
Yeah. Now, I think a big part of why we get conspiracy theories about the collapses of the World Trade Center is that people don't understand how it could have collapsed. They think it's this incredibly strong structure, and they think it's just highly implausible that even if there was damage at the top, the progressive collapse would go all the way to the bottom. Is this something that when you obviously you saw the original collapses on TV, and you were on the site and you saw the results? Did you fairly quickly come to some kind of idea in your mind about how you thought the building collapsed? Was this something you gave much thought to?
I didn't give a lot of thought to a specific trigger for the collapse. What everybody on site knew about the towers 1 and 2 was that they had a relatively rigid exterior tube structure, a bunch of columns and sort of normal floors in the core, and in between were very long span trusses, which are much lighter weight than the beams that might ordinarily be used. All of the lateral rigidity of the buildings was in the exterior. So it's easy in a case like that to see that once that no longer functions for whatever reason, one reason being a big gaping hole where a plane hit the building, that the interior of the building is not going to be strong enough to stand up. If you had the plane impact with no fire, if you can picture such a thing, the towers would have stood up, but they would have been extremely weak for lateral loading, so that a 30 or 40 mile an hour wind might have been enough to bring them down. Wow. Because the lateral system of the building was compromised by having a big section of it forcibly removed. The floor trusses were, for the most part, unrecognizable. They were just too weak, and they crumpled up as the buildings collapsed. The exterior columns are what made for a lot of the dramatic pictures that you saw in the news, because they were assembled in sections, and for the most part, they failed at the joints between sections, and a section would be 3 columns. So if you look at the original photographs afterwards, you see a lot of 3 columns in a row. Mm-hmm. That's a section of the original exterior, and it broke apart at the splices where it joined the neighboring sections.
It's interesting. You mentioned the lateral load is all on the exterior. Is that just talking about the wind load for the building, I suppose, and seismic loads?
The buildings were built before New York City had earthquake load as part of its requirements. So it didn't come in until 1996. So they were designed for wind. They were designed for wind under the 1968. Actually, I think under the 68 building code. They're old enough. They may have been designed under the 1938 building code, but I don't think so. I believe they were designed under the 68 building code. The wind loads are somewhat lower than would be required today, not drastically so.
Yeah. I just want to make sure I understand, like, when you're talking about lateral loads, like say if you were to delicately remove the exterior and the floors, and you were just left with the core, would that core column be able to, the core of the building, be self-supporting?
It would be self-supporting for gravity, but it would basically be a house of cards. It would have very little lateral rigidity.
Wow.
So a wind load much less than the code required wind load in 1968 or now would be enough to destroy that. So yeah, it's what's called a tube structure. It was invented in the 60s, where you have closely spaced columns and beams at the exterior of the building, and that serves as your lateral bracing. John Hancock in Chicago is a tube structure. There are any number of them here in New York. So it was for a while sort of the in vogue method of structural design for tall buildings.
Yeah, and that kind of makes sense now. Like when you think about how it collapsed, like you talked about the floor trusses being all mangled. There weren't very many recognizable floor trusses in the debris pile, and they essentially would have been stripped away by the falling mass of the building above, like in a very chaotic manner, and then just reduced to rubble as they went down.
Yeah, they were just crushed.
Some people think of the floors kind of pancaking, and then kind of neatly coming down like a I don't know, like a house of cards, just go bam, 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 and then stacking up. But you're talking about the trusses being all just this mangled mess, and just not really stacked on top of each other.
It depends where you are in the building. So if you think about it, the collapse did not begin with the uppermost floors. It began at the floors that were most heavily weakened by fire, which were somewhat lower. And the top of the building sort of came down with the collapse, and then itself sort of impacted the ground, impacted the rubble below it. Each floor down, once the collapse starts, is getting a heavier impact than the one before. So by the time the second floor collapses, it's got the weight of 100 floors on its back. That's why things were so badly pulverized, because it just the effect adds up as you come down the building. I did a incredibly crude calculation on this, just looking at the average floor height and falling to the ground. Never minding the effect of fire, just if you just had 110 floors at the elevation they're at and you let them fall. And that very crude calculation gave me a kinetic energy that is about 10% of the Hiroshima bomb.
Wow.
So, things got destroyed.
Yeah. It's a lot of energy. Did you have similar thoughts about Building 7, or was that even kind of on your radar in terms of how it had collapsed?
It was on my radar because it was a roadblock that I had to walk around all the time.
Right.
The thing is, I didn't think a great deal about it because I knew one thing that had become public knowledge on the 11th or on the 12th, which was that building caught fire when the North Tower collapsed. When the North Tower collapsed, the fire department was very badly disorganized. A large number of firefighters were dead. A large number of officers were dead as well, and the dust in the air prevented their radios from working. So the fire department upper officers made the decision to not attempt to fight the fire in number 7 because they believed that they would not be able to put it out, and what it would do is get a couple of hundred more firefighters killed for nothing.
Yeah.
I think it was the correct decision. Everyone I've spoken to thinks it was the correct decision. But what that means is what you have is an uncontrolled fire in a 45, 47-story building, which is not something you see very often.
Yeah, and you talk about examining the debris pile, or your experience of being there by the debris pile. And one thing you mentioned was the fires. And this is another thing that people get kind of suspicious about. And you talk about how how much actually flammable material there was in the building.
Yeah. People think flammable material, I'm looking around my office, people think flammable material is paper and books and things like that. The plastic that's used for furniture will burn. Mm. Carpeting burns. There's a lot of things that will burn in an office if you get them hot enough, and most of them are poisonous when they burn. You really don't want to be around burning plastic if you can avoid it. So when all that stuff gets trapped in a confined space, it's like, an underground tire fire. There's not enough oxygen for it to get burned hot and just burn itself out. So it just sort of smolders for a very long time. And it was a couple of months before the fires were finally out, because there was all of this flammable material down in the cellar hole of the entire complex being fed a little bit of oxygen. So the fire just kept going.
And then it would occasionally flare up, I guess, when it was exposed to oxygen, when the bits got uncovered.
Yes. And there were hoses at the site to deal with that.
Right. A big kind of conspiracy thing there is that they claim that there was molten steel, liquid molten steel, on the site in the fires. Did you ever hear of anything like that or see anything like that?
Nope. The only place I ever saw anything that looked remotely like that was some of the video before the collapses, and it was pretty clear that the molten material was aluminum from the facade, which melts at a much lower temperature than steel. I never heard anybody talking about anything like molten steel on site. I never saw anything. I never saw any metal that showed signs of having melted. I saw metal that was twisted and bent in all sorts of different shapes, but never anything that had melted. It's a different appearance.
Yeah, and you had been in all parts of the site. Like I think you went down a hole in the street that would have been like kind of next to Building 7, so you would have seen basically the bottom of the pile as it was.
Well, actually, that hole led to a garage that the area that we were in was almost untouched. The south end of it was crushed, but the part where we went down in the hole, it was that was November already by the time that happened, and it was here's where people parked their cars on the morning of the 11th.
Yeah.
But no, I was all over immediately adjacent to collapsed steel, and I never saw anything like that.
Yeah, and I imagine you wouldn't have seen things that looked like evidence of explosives. I mean, I feel kind of silly asking this, but like, is this something that was even on anybody's radar at the time? Were they thinking like that they would look at for evidence?
Well, I mean, I think the conspiracy theory started pretty quickly. I remember hearing people saying, "Boy, that looked just like a controlled demolition," while I was still on site. I would not have recognized anything like that. I don't think anybody would have been able to tell the difference necessarily, unless they were a specialist in bomb explosions. It's funny. As one of the people at Thornton Thomas Study who had worked on this, they got involved later on with a lot of the litigation work, and I wasn't particularly involved with that, but I had been on site, so I was asked to review certain photographs and certain videos from my recollection of those areas. And I remember people saying that the way that you saw debris and smoke moving outwards during the collapses was evidence of controlled demolition. And that's the effect I was talking to you about before, where the air inside between two floors has nowhere to go but out, radially outwards, as the building pancakes. So, something that was pointed to as evidence of an explosion had a much simpler explanation. Yeah,
I've seen that before. They describe it as a pyroclastic flow because you get similar dust clouds in volcanic explosions, and they think this somehow indicates it must have been an explosion. But if you look at building collapses that just collapse by without explosives, you get this kind of similar dust cloud, or things like rock falls and things like that. You get the exact same cloud of dust because, as you say, it's the air being displaced.
Yeah,
Yeah, another thing that people point to is the columns that were cut after during the cleanup. They did a lot of removal of the columns that were still standing, so they had to cut them, and sometimes they would cut them at an angle, and people claimed that you would never cut a column at an angle. Do you have any thoughts about why the columns were cut at an angle during cleanup? Because
of the pile of debris. I want to emphasize that as of the 11th, as of the evening of the 11th, there was nothing left of 1 and 2 that resembled a building in any way. It's not like there was a building with a big pile of stuff on top of it. Mm-hmm. There was nothing left that looked like a building. The description that I've used for this is pickup sticks. It was just this random distribution of the columns that had survived. Some of them were straight, some of them were not. And they were pointing in every possible direction. They were cut at an angle, basically, so there were cranes at the perimeter trying to pick up these pieces of steel that are tangled in with each other and that are at all different angles, and they cut them wherever they needed to cut them to get a piece free to move it out.
Right.
If you're demolishing a building, you would never cut a column at an angle because you're taking a building down, and you want to have things continue to function as you come down floor by floor. When you're dealing with a pile of debris, it's a different situation.
You looked at a lot of the damage to other buildings, like in particular, like one that stands out is 130 Liberty, which had this huge gash in the front of it with a very large piece of the facade, I believe, of the South Tower in it.
Yes.
And that had quite a bit of structural damage to it. Was there any danger of collapse, do you think, from of that building? Was it ever in danger?
The building as a whole, no, it wasn't. 130 Liberty was structurally anomalous in the opposite way of the World Trade Center. It was heavier than it needed to be. My understanding, it had been built by Irving Trust Bank originally, which is long gone now, as a place where they would have trading floors. And they didn't know how many trading floors they would have. Were they going to rent out space to people who would put in trading floors? And trading floors, in terms of structural design, are heavier than normal office space. So what they did was they designed the whole building for literally twice the live load of a normal office building. That gave them maximum flexibility of what to do with it. And it had a traditional lateral load system. It didn't have a tube system. So the having the gash on the north face did not significantly reduce its lateral stability. Right. So the building was dangerous because every single window was smashed. Pieces of the metal facade panels were loose. So it could kill somebody walking by just dropping 5 pounds of debris onto them.
Yeah. But
the building as a whole was not unstable.
So I guess World Trade Center 7 was a similar distance away from the towers as 130 Liberty. Not entirely sure, but it was some distance away, so it suffered similar kinds of damage. Would there have been differences in the effect of the damage on Building 7 because of its different design versus 130 Liberty?
I don't know as a fact. I suspect 130 Liberty was a stronger building than 7. The biggest difference between them is, as far as I know, there was very little fire spread in 130 Liberty. It didn't. The debris that hit it wasn't on fire. And for example, at 7, the fires at the top floors were rather small and basically extinguished themselves because they didn't spread, so they ran out of fuel. So the fires at the lower floors that spread. So there may have been some small fires at 130 Liberty, but they didn't continue to burn.
Yeah.
That's the big difference, I believe, between the two buildings.
Yeah, definitely. Well, yeah, you could see a huge amount of fire in World Trade Center 7.
Yeah.
Another building is 1 Liberty Plaza. And it was interesting, you wrote about this in the book, is that there were a lot of rumors going around that 1 Liberty Plaza was going to collapse. And you went and looked at it, and you saw that it wasn't. And then you kind of tried to tamp down the rumors by spreading what you called like counter rumors.
Yeah. spreading the counter rumor was probably me being, at that time, sort of on edge and very tired. There's an optical illusion that anybody can perform with. You need a building about 10 stories or more tall. And what you do is you walk right up to the building, get your belly touching it, and look up. And if you do that, it looks like the building is leaning over you. Something to do with the way our eyes and brain function. And people were very on edge. I think in part because of 7 World Trade Center more than the other two, because given the extent of plane damage, it was shocking but not exactly unexpected that 1 and 2 would collapse. 7 didn't have that, and I think it was sort of in people's heads, here's a building that didn't look so bad, and it collapsed. So every little thing got followed up. And I think people from Thornton Tomasetti went up to the top of this, using the stairs of 1 Liberty, 4 or 5 times, looking for damage, because somebody said, it doesn't look right. And there was nothing wrong with the building. Literally nothing wrong with it.
Yeah.
So, it's to me evidence that even people who deal with this stuff for a living get spooked. And they you see a pattern even when it's not there. So the pattern was the building was near the site. It's a tall building. It collapsed. Maybe 1 Liberty's going to collapse next.
Yeah, certainly. I mean, it's like all bets are off after you've seen what you've seen that day, because it's something no one's experienced before. You imagine your mind goes wild. Let's talk a little bit about I sent you the Hulsey report, which is this report done by the University of Alaska, and I kind of asked you for your general impression of it. How would you kind of characterize like what you've seen of it so far?
Well, I didn't find it very convincing, is I guess the best way to put it. I feel like they made a bunch of assumptions, some of which are not very well thought out. They begin by saying that they're not sure about the extent of the temperatures that were inside. Again, this is a building that was on fire with no real attempt to put out the fire, no attempt to fight it, no sign that the sprinklers functioned properly. Fires get extremely hot. It's the reason that you're taught to stay down at the floor. The fire at the ceiling in a case like this is going to be somewhere above 2,000 degrees Fahrenheit. And that is enough to basically destroy structure. It doesn't melt the steel. It weakens it. And when the steel is weak, it will start to collapse. And in that report, they extensively modeled the building, but they're assuming that all the members are present. And if fires a couple of floors away from the area they're looking had weakened beams that are bracing columns, then the frame wouldn't function the way that their model assumes it functions. So they did not seem to take this into account, and maybe they did, and it's not written up very well. I can't say for certain. But anytime I see that they're modeling the whole frame, but they're only talking about the effective temperature at the specific column they're looking at, I'm not so sure that makes much sense.
Yeah, definitely. I think they didn't really account for that. And when they were doing simulations, it seemed like they were just simply removing a section of a column and leaving the rest of the building untouched.
That method actually has a long history to it. That method has been used in other countries, and particularly in the UK, as a form of modeling for bomb blast since at least the 80s and maybe earlier than that. And it's actually in the New York City Building Code now in terms of resilience as one of the methods to check on the building's resilience is to remove key members. So that method makes sense, but it's not a model of a specific event that you're trying to recreate.
Yeah, it would make sense if you were modeling a bomb, like the 1993 World Trade Center attacks.
Yes.
Well, just a bomb on one column. Even then, I suppose there would have been a lot of force, blast force on the floors and beams around the column as well. So, You're still not getting an entirely accurate thing, but it gives you a baseline of, if this column is taken out, what will happen. But not entirely accurate. Did you look at the video I made, kind of like looking into the static versus dynamic modeling that they did?
No, I did not. I didn't have time for that.
Yeah. No, it was just that it seems like they modeled it using static analysis. And correct me if I'm wrong, a static analysis would be where you're just measuring kind of the deformation of a building under a load, like how much the members will deflect. And it's not really something you would do for measuring an actual in-process collapse.
It can be part of that analysis, but you're correct that it's not sufficient. Up until, let's say, the 1960s, tall building design was typically done only statically, because it's a great deal of computation to do dynamic analysis. Tall buildings, and particularly slender tall buildings, now regularly get dynamic analysis as part of their original design. I suspect there was some dynamic analysis at the World Trade Center, but I don't know. I've read various interviews with Les Robertson, took place after the 11th, and it seems that it was a very thorough design. They did not make any decisions lightly, but you can do a lot with static analysis, but it has its limits.
Yeah, they push the static analysis to the extent that they show the building tipping over, and it's at about 30, 40 degrees. And it seems like that's kind of, to me, like an inappropriate use of static analysis, because the building is actually moving at that point. If a building is tipped over 40 degrees, then can you still say that static analysis is valid for that situation?
Well, I don't think it's a realistic model. If you tip one of these buildings 40 degrees, you're going to have all sorts of secondary effects that are not part of a normal static analysis. If a building is tipped over like that, then gravity load is causing bending in the building in a way that it doesn't when the building is vertical. I don't know how you're going to take that into account in a static analysis unless you do a series of such analyses at sort of every angle of tilt, which seems to not be what they did.
Yeah, because a static analysis kind of ignores the time component.
Yes, and impact.
Yeah. So like the momentum of things and things hitting other things, and if a building starts to tip, it's going to continue to tip. It's not just a static force. I think that they tried to replicate NIST's analysis, and they did it by removing a line of 3 columns and then removing another set of 3 columns, and then things started to fail progressively. Like all the columns, the loads were transferred to the other columns, and they failed. But they kind of used this to make it seem like the building would actually tip over, and I think to do that they would have to know at what time the columns failed. Because if they all failed within half a second or within 2 or 3 seconds, the building wouldn't actually have the time to tip over. So you couldn't really say that it had tipped over. But I think there's a lot of questions around their report and that type of thing. A quick question, like in Professor Hulsey's presentation that he gave, he mentioned that the building had been evacuated and there wouldn't be a live load of the people within the building, and that would make a difference to the calculations. Do you think that would actually make a significant difference, the people being evacuated out of the building?
Normal office space, people are a real but part of the load, but well under half. Normal office space, furniture and papers and contents weighs more than people. Yeah. So yes, the building was somewhat lighter because the loads were somewhat lighter because of that.
Yeah,
it's getting into the details of the analysis, and I'm not sure either that he knows or that I know exactly what NIST did in their analysis.
Yeah, I don't think I don't remember the live load being mentioned in NIST's analysis. But it's not just the people; it's the floors themselves, which are the mass of the building. But they're not live load; they're dead load. But not moving.
Yeah.
But so, kind of a general thing, kind of closing up here. Like, it's very hard to get people to talk about this type of thing. You're an engineer, you're an expert on this type of things, and you were on the site, so it's great. You have this really great perspective on it. But I find it very hard to get people like engineers or scientists to talk about conspiracy theories. What's your sense about how 9/11 conspiracy theories are viewed within the engineering community?
I've never met a structural engineer, a practicing structural engineer, who believes them. That doesn't mean that such people don't exist. I'm sure they do. But you would think that if there was something funny about what happened here, that engineers in New York would be aware of it. And there's really no sign that anybody here believes that kind of theory. It is sort of fascinating to me that so much of the conspiracy theory comes from people who are quite far away and don't necessarily spend a lot of time dealing with tall buildings, and don't necessarily actual tall buildings as opposed to theory, and don't necessarily spend a lot of time dealing with tall buildings that have real life problems. For example, the World Trade Center was built with asbestos fireproofing, and not number 7, numbers 1 and 2. Mm-hmm. And that was outlawed not very long after the buildings were completed. And the way that the Port Authority, which owned the buildings, was dealing with it was when a floor came empty, they stripped it out. Mm. It was considered to be, people are not being exposed if it's hidden in a ceiling space. But anytime there was going to be demolition work, then the whole floor was abated. And the new fireproofing that was used in the late 70s and the 80s turns out had a problem with adhering to steel. So the asbestos may have been pretty close to 100% gone by 2001, but there were a number of floors that had fireproofing that worked great if everything was static. But of course, the impact of the airplanes caused both buildings to move much more than normal movement, and it came suddenly. It's not like a wind that builds up. It was a sharp impact. And it's quite likely that a lot of fireproofing simply fell off of the floor trusses when that happened, which is something that, this problem is known. No way to ever know the extent of what actually happened, right?
Yeah.
Somebody would have had to inspect the building in between the impact and the collapse to know exactly what had happened. So the ability of the buildings to withstand fire may have been significantly reduced, but we don't know how much. And when people say, how could this happen? Well, this is a real life kind of problem. In a computer frame analysis, you say, okay, the temperature is this, the temperature curve is going to look like this as the steel heats up. But maybe that's not accurate. And it doesn't take that much unprotected steel failing in a fire to cause a failure in a building like this, because, again, all the lateral resistance was in the perimeter and the floors were lightweight trusses. Mm-hmm. So you could easily have a sort of a combination of effects not foreseen. Conspiracy theories tend to happen because something happens that people don't expect, and they don't want to accept that something could happen that no one predicted. I don't know. Again, the engineers I know, not a single one of us said that these buildings were going to pancake. But in retrospect, it's not very surprising. So mm-hmm. People don't like that combination, something that's unexpected and horrible.
Yeah. Do you ever meet conspiracy theorists, like in real life, and have to explain things to them?
In person, no.
Yeah.
In person, no. I have occasionally come across them online, and I simply walk away.
Right.
I'm not interested in it. What I always recommend, I've had friends say, this guy is telling me this about the World Trade Center. What should I tell him? And actually, one of the best debunkings of the conspiracy theory was from Popular Mechanics. They put out a very nice little book explaining why all of the common conspiracy theories were wrong. And I recommend that to people.
Yeah, me too. It's a good book. Although, of course, they've got excuses around that now, so it just keeps going on.
Yeah.
Yeah. All right. Well, I want to thank you very much for talking to me. I mean, you say like you wouldn't talk to conspiracy theorists, but this topic, I think, I really appreciate getting your perspective on it, and I wish I could get more engineers to kind of weigh in on what they think about the whole topic, even if it's just to say that they think it's ridiculous. Because I think there's this idea that all these engineers are cowering in the wings because they don't want to talk about it because it's too scary. When I think really it's more like they don't want to talk about it because it's so ridiculous.
I think that's more likely, yeah.
Yeah. All right. Well, that's great. That was very, very interesting. Do you have anything you want to add? Any final words?
I building code bodies, the ICC, which writes the International Building Code, which is the base building code for the whole country. The committees here in New York that write the New York version of the IBC really have taken this stuff into account over the last 18 years. And it's frustrating that the engineering community is trying to learn from what failed. And there are people, the conspiracy theorists, who are basically saying, well, that lesson doesn't mean anything because that's not what happened. Engineering advances by studying failure. That's been true since structural engineering has existed. You look at what went wrong last time and you try to improve on it. That's what engineers are doing right now.
Yeah, and they're basing it on the reality of the situation rather than the conspiracy theories. All right.
Yeah.
Well, again, thank you very much.